All right, welcome to my talk, Dependency Injection in C++. In and of itself, not a wowing title. There are quite a few talks out there with dependency injection in the title. The second part of it is the key part of what I'm doing in this talk and why I've bothered to give it. It's a practical guide. In other words, what are we going to do when we're actually out there in the real world trying to do it? So, I'm in Bloomberg. This is the screen I put up because I'm in Bloomberg. So I'm an engineer. Who am I? Who is this guy up here in front talking about dependency injection? That's my headshot from CppNow. I kind of like it. I started using C++ professionally a long time ago. I don't want to do the math, but it's probably like 30 years ago. And my professional career has mainly been doing system analysis. I spent 21 years as a consultant, just means that I've seen a lot of places. And I've been the last decade or so in Bloomberg. And right now, I've been in a few places, but the last couple of years I've been in Bloomberg and Ticker Plant, which is where we take all that information from all the exchanges around the world and produce the ticks from it. All right, what do I do when I come to conferences and talk? Who here has been to a talk of mine before? All right, so you know I focus on the practical, right? Not the theoretical or what we're going to get or maybe get. So it's usually based in the real world, something I've done. I try to demonstrate these principles in practice so that you can see how what I'm saying graphs to reality. And I hope you're able to take something away and use it Monday morning, right? So that you take something away from it. If you have questions, and you can kind of shout out questions, but if you want to wait, to some better time, take the slide number, it's in the bottom right. And let's go, where will we be going on this talk? Like, what's this talk going to happen? Well, there's going to be all kinds of talk about interfaces and functional contracts, and that's how you kind of size up your dependency injection. We're going to look at various automatic dependency injecting frameworks, right? Because your code isn't complicated enough as it is, so you're going to use these things to give you the nice error messages. It's going to be rooted in toy example systems and a lot of theory pumping. And we're going to have a bunch of highbrow talk about keeping everything as a passed-in parameter. All right, so that's where we're going today. No, it's not where we're going today, right? This is what I found out there when I went to look up dependency injection. A lot of this stuff going on, and I didn't find it particularly helpful. So where we're actually going to be going today is we're going to be using dependency injection in real applications, right? And we're going to look at the various methods. I got to cover the basics, even if you guys know them. How we're going to achieve functionality swapping, instrumentation gathering for flexibility and testability. And we're going to focus on the strategies. That's going to be the main part of the talk. How to think to achieve dependency injection in your real world applications, because it's not that easy. Without warping your production code into being really strange looking because you added testing in, right? Or just giving up, throwing your hands up and saying, it's just too big a job, right? And it's going to be rooted in the real world, not theory, because the last 3 months I have been living this particular dream in taking the large code base that we use to process all that information and trying to break it down. There was no dependency injection in it, and there was no real testability of unit testing. All right, so this is the lessons I learned while doing that. So let's start with some dependency injection myths that I've found. I was going to say lies, but that's too strong, right? It's simple. That's one of the things it says. No, it's not, and I'm going to show you why, all right? Only for simplistic systems or small parts of real systems. That's probably just to keep number one roughly true, right? But it's not really. It's overkill on smaller projects, right? Because smaller projects never grow into big ones, right? So why would you put it in? And one of the it's simple is probably the biggest myth, but the next one is forget it for now, because it's going to be easy to add in later, all right? I think what that means my customers or my clients are going to be my testers, because I'm not putting the testing in now, I'll put it in later, after I get into production, because that works better, right? No, it doesn't. And only for testing. Dependency injection is used a lot for testing because it's the immediate use case you see for it. But if you have code that's properly composed and has that dependency injection, you can swap large parts of functionality out to make your application do more varied things than it was originally designed for. Okay, so it's not just for testing. So what happens when you test without dependency injection? All right, which is kind of what I found the state of the code base that I was working in. Well, we have what I call pocket universe testing. And what that means, I have to set up a fully functional environment that kind of keeps all my components happy. And that means I got to set up some sort of like bare configurations, databases, maybe components, just enough to get myself that I can do the test. All right. Well, once you test this way, you're not doing unit testing, because what happens when you engage all parts of a system simultaneously? All right. You get integration testing, right, which has its place, but it's not unit testing. And because it's integration testing, when you find an error, it's kind of like something blows up and you don't know where in the system. It's a much bigger error investigation. Setting up the tests are even much trickier, because you got to figure out all the little pieces you got to touch to add in this new piece of testing. And you're usually not sure if you did a full test, all right? You put some stuff in, you hope you cover it. And lots of times this leans entirely on regression testing. Here's what I got last week. Here's what I got this week. I'm not quite sure what that is, but I want to make sure it's the same. So this does not take the place of your unit testing, right? So what is the essence, and I didn't steal this off a talk yesterday, what is the essence of dependency injection, right? What is it, the key thing you have to know? And what you have to know is, where are the injection points? What are the injection points in your system? And I think it's helpful to break a system down into your very base data holder types. All right, these are the things that just hold plain data. They're not very complicated usually, and they act as dependency injection points into what I'll call base implementation of functionality. So here I have stuff that holds various little clumps of information on the financial side, and they can be passed into these other base implementations. Pricing might get, I want the mid. So I got a bid and an ask, here's what someone willing to pay, what I'm willing to accept. And I add them and divide them by 2. That's a base functionality. I can test it easy by just putting data into my base components, right? These base implementations then become components for dependency injection into your higher level classes that marshal these base functionalities together to do real operations. And the marshalling classes can also be components of higher up, so you can layer that up as far as dependencies go. So let's get through the basics. I got to get through this. Ways to inject different functionality, and your granddaddy's way of doing it was at link time. Okay, so using link time dependency injection, and that's a lot of what I found in the code base I'm working in. So you use link time to switch in different functionality. And that allows you some limited testing, but it has the advantage if you don't have to do anything to your code base, right? Your actual code just sits there, no contamination of the testing whatsoever, because you're reaching in externally and putting different functionality in, either by pulling in a different .o, different lib path, all right, or if-def, right? If-def testing, then do this, else do the production thing, all right? So what does that look like? Well, you're going to have twin implementations, one for production with all the real functionality in it. You'll have one for testing, which will be some sort of simpler, less dependency pulling in for the pieces you're pushing in. And these things will generally live in some alternate code branch. It'll have test or something off your main branch. So it sits in there. And because of that, you have one link, one test scenario. So if you build all your tests in one shot, which lots of projects do, you have one set of tests you can do. If you build a whole lot of little test executables, well, okay, how many of these do you want to build, right? How many targets in your make file to pull different stuff in? All right, and it looks something like this. So here I have, this is an action handler. I got something in there that's going to send a request. So that's my dependency. And in my real com.cpp, I have stuff which connects to a server, checks that I have routing information. There's a whole pile of stuff. And then when it gets to request, it's going to actually send it off, right? But I can also have my test/com.cpp, And what it does is it says, look, I'm just going to grab and put it in some extern global. And then somewhere else where I'm doing my testing, I can just reach and pull that out, right? I can say that's a dependency. So anyone see problems with this? Any drawbacks?
You got to maintain your APIs and everything in two places.
Yeah, right. The logistics of unit testing many components with all these different linkings is impractical. You generally start getting undefined, at least I did when I changed the class. I get ODR violations, undefined behavior. It's a very fragile stack of cards that when you put something in, like a virtual function or something, the things blow up, right? And if you do any instrumentation, it also blows up. And also it's more like integration testing because you're essentially doing all the parts of the system again when you do the link. And it's brittle and confusing, all right? And being brittle and confusing, I say don't use it, all right? It should not be used. It's something that was part of a bygone age. Yes, Chris?
I was going to say, it also starts to run into additional problems with transitive linking if you have like a big code base that actually has to bullet points,
right. Yeah, I think that comes down to one part of the code might still trying to be looked at, right, the real one, and one part hasn't, and you're trying to bring them together. You get all kinds of problems, and ask me how I know, because I got these problems, right? It's really nasty, and you think you can figure it out, it takes a lot of time, all right? So linking, I'm taking off the table. Don't use it. If you use it, you're not a nice person, all right? So what about the next thing? Inheritance and virtual functions. Well, when we do this dependency injection, what we're going to do is create a base class. All right, and we're going to extend from that our various ways of testing stuff, or implementing stuff. So this has the advantages of lots of methods can be on your base class, so you can have a rich interface. It's well understood, all right, inheritance and virtual functions have been there since the get-go, right, and lots of code bases use it. All right, and it's easier to add to all the code bases this way because they use so much inheritance, all right, so it kind of slips in there. And that looks a bit like this. So here I have a class called CalcEngine, which has a couple of functions in it. And I have some function which is going to use that CalcEngine. And here is my dependency I'm looking to test. I want to see what's been passed into that apply function. So what I can do, well, the injection happens up at the top, all right? So what I can do is just derive my test CalcEngine from this, and then drop that in when I'm doing the testing into this function. Right, and I can capture everything that's been given and control the outputs that have been given back, okay? So that's one way of doing it. The other way of doing it is you can have an interface. Again, it's quite popular. You put a pure virtual interface together, and that will derive our real CalcEngine on one side and our test on the other, and we can drop them in. And this is quite standard, so you can just put your mocks in here. You don't actually write stub classes as is, all right? Anyone have a preference from extending from the real class versus an interface and extending off both?
I prefer the interface.
Why is that?
It's more modern and it's simpler to deal with.
Oh, interesting. I'm going to tell you why I don't like it, just in a slide or two, though.
Also, solid design principle depend on abstraction interface rather than concrete implementation.
Okay. Yeah. No, they're good arguments. All right. Yes?
I find that when you do it from a base class, there are side effects that the base class expects in those derived functions, in those extra things that you're trying to override.
Right. Well, let me tell you what I had as a personal experience. I had a class that had already an interface on it, and it was great. And I was, like I said, I was adding some unit testing. So I went to derive off the interface, and there was 165 virtual functions, pure virtual functions on it, all right, of which I needed one, and no one had ever bothered mocking any of this out before because we didn't have injection, right? So I actually had to go to the default, right, the one who implemented the 165 and derive off that because I just didn't feel like spending my afternoons putting in 165 dummy functions. So that's one of the drawbacks. Andy?
It seems like more of a drawback of that particular interface that has way too many things in it than...
That is the root of the problem. Yeah, we're dealing with the effects of that, all right? And we're going to come across that. Roy?
So when you did that and just over in one function,
did your like test implementation just copy or keep the results or manage them and then call the base class just to keep functionality?
No, it just derived off the, I don't hit the other 164 functions. So all it is derived off, I mocked one method, and now I can do my unit testing and I'm happy and on my way. Now in other, as Andy said, this is a symptom of a bigger thing we're going to look at a little further on. All right, but it does show that, you know, people want to get very formal with interfaces, you can go too far down that path. All right. By the way, does anyone know if you create the same assembler code, right, if you do it either way? Is there any advantage to just one versus the diamond? No? Keep wanting to look at that, but never have the time. All right, so what are the drawbacks of this? Well, the interface can become messy. People start adding purely test functions into it, because why not? It's kind of a collector, all right, of stuff. You can start getting data mixed in with interfaces, right? So it's not just pure interfaces anymore. People put data and stuff in there. And it uses the virtual function table, so there's an extra hop. I don't know, there's maybe an extra hop. All right, theoretically there's one, but I added virtual functions to an interface, and I looked in production at timings when it got better in timings, and I wasn't sure why, but I think sometimes they get elided. So anyone, any questions on virtual? It's simple stuff, right? I mean, we all know it. Let's go into templates. So another way of injecting it is with templates. So we just create a class that satisfies whatever that template parameter is being called on, right? So we can handle lots of methods like before. We only need to find methods that are actually used. We don't have to, you know, we don't have to do 164 of them. We can just do the ones we need. It's compile time, so we have no runtime overhead. So that's got to be good, right? And templates are just the way we do things. Like, it's kind of cool, all right? And if you want to be uber cool, you can use the concepts, which I think we got in C++20, right, to define the equivalent of an interface for a template. So how's that going to look? Well, here I have my process function now that's with template dependency injection. Here's my dependency I want to get my hands on, and here's where I'm injecting it. All right, so I have a real calc engine which has all kinds of stuff. It's going to databases, it's getting other information to figure out what the calculation should be. And over here I can do my simple test calc engine, right? And if I'm using, which I use the Google mock stuff, I just mock it out, all right? So this is the state of the game, I think, till 2017 came along. And then when 2017 came along, we got the nice thing of, right, the template concepts. So what I can do here is say, look, my calc engine requires a calculate that takes this const data and returns something that looks like a bool for these two functions, all right? I think I'm now in the territory where I can't just say, well, the template functions that aren't used don't get instantiated. Well, I'm going to fail a concept, so I'm, you know, it's kind of, we've added some structure and maybe taken a bit of flexibility out, all right? But overall, I like concepts, all right? It's better error messages. And that means my template type changes to a calc engine T instead of just a generic type name. Yes?
What do you mean by that? Like, you've lost some flexibility? I didn't follow that.
Oh, if I don't use a concept and I drop something in which doesn't have all the functions that's needed on the calc engine class for all the functions it's dropped into.
Oh, so you're saying if you could have this, like, you have to define for this one, and if you have a different.
Yeah, even though I'm testing process, here I'm testing process. Maybe there's a couple of apply functions that use completely different parts of the calc engine. I got to do them all if I have an interface.
I'd argue that's better, because now you're being very specific
Well,
about what you need.
that's an argument we can have off camera. But yeah, it's not a bad thing. It's something you have to think about. That's all. Right? You got to think. Yes.
For all these cases we're discussing, are these user-facing interfaces or internal-facing interfaces?
Someone's using them, so they're user. All right. I don't distinguish. It's just how flexible you can be with your users.
Do we care at all about preventing users from using the openings we've made for testing purposes or not intended purposes?
That's a bigger discussion I can have. My thing is, if you want to shoot yourself in the foot, do it, right? But not make it easy. All right, but that's a big discussion.
Yeah, Peter. Here.
Oh.
Just two small things.
Hmm?
Concepts were added in C++20, not 17.
I said 20.
You said 17.
Up to 17, meaning when we go by it.
Sorry. It's not my first language, guys. And the second thing is, you said something about doing it in compile time. What do you mean in compile time? The functions will
No.
compile-
In other words, there's no extra virtual function hop.
Oh.
That's all. All right. So what are the drawbacks of templates? Can anyone guess what a drawback of using templates is?
Everything in headers?
You have to use templates.
What was that?
You have to use templates.
Yeah. Templates all the way down. All right. Because you add a template, right? Now your template's all the way down. There's some tricks you can do to stop it, but they're not that easy. And it's hard to add in legacy code because they're more, usually if it's legacy, it's more inheritance based, and it's hard to bring templates in without making a massive change. A massive change means you don't get to make any change, all right? You can get increased compilation times, and it's more hieroglyphical, just it's harder to read. Now we're getting better with the autos and stuff like this, but it's harder to read. And that's all I'm gonna say on templates. Anyone got any issue with me? Yes.
I guess I don't see what the sort of template pollution would be. I mean, if it's a class that has an interface, and then I just say, hey, now it has a requires, I'll take any class that conforms to this requires, you could drop that in right in the middle of the code base. You don't have to bring it.
Now if I have a
all
class that's all of a sudden I just put a template parameter on it, right? Now
But
I
you
got
could put it at the function itself. You don't have to put it at the class level.
Yes, and then maybe the functions all the way down from there have to be templatized. It's kind of a template poisoning, right? I mean, it can be done, and it depends how local you can keep that change, right? So if you can localize that into the one spot, then yeah, you can go ahead with it, right? But it is a potential drawback. All right, and then the another one we're going to look at is type erasure, which I think is C++ 11-ish for the stud function. Other new stuff is coming along, the move only function. So here we have anything that satisfies my particular function signature, I can just invoke the call on it, right? I don't care where it is or who has it. As long as it takes my arguments and gives me my result, I'm good. And that means it's invocable on any callable target, and it's usually pretty versatile. All right, I end up seemingly using a lot. All right. So how does that look? Well, here what we have is we call our dependency type a stud function. In this case here, I'm going to take this constat and some other stuff and return a double. And I have this yield processor class, and here's my dependency. All right, it sits in the class, and I put that dependency and I inject it in the constructor. And now I can test this thing here. I can drop in my own test. Maybe the regular yield calculator drags in a ton of stuff to try and do it, right? And even building my test would be a huge link line. I can cut all that nonsense out and just say, return me a simple calculation. All right. And I haven't shown the test. I'm going to show one Google test. All right, that's it. Because all the rest of them look like this. So if I'm testing that yield, here is my dependency I'm dropping in. It's going to be something that's just going to give me a tenth of whatever yield.data is. Here's where I inject it into my yield processor. All right, here's where I call it to see if it works properly. And here's where I can verify I got the right results. All right, and this is what we want for unit testing. And if I know how this thing works as a black box, I can set all these tests up, and I don't have to drag in a really complicated calculator because I'm not that interested in it, right? So.
But doesn't it mean that you have to follow that pattern throughout your entire code base?
Do I have to do what?
You have to follow that pattern of injecting your type erasure object through all the constructors of type that you want to test.
Of that particular class, yes. Yes. Or you have defaults that slip in, but yes. Yeah. What are the drawbacks? Well, you can only handle one method at a time. So if I've got 15 dependencies, I've got 15 stud functions been dropped in the constructor, and that's not really seen as good practice. You probably won't get that through a code review. You can't substitute a class for the you can't substitute for a class instance. And it's similar overhead to a runtime virtual call. I don't know if the compiler can elide it easier. To me, it should be the same, but I haven't actually looked. So this is my tribal knowledge. So that's type erasure. Anyone problems with that? Cool, all right. So let's talk about null-valued objects, which it doesn't really matter which of the previous you're doing, but null-valued objects are something that shows up a lot when you're doing unit testing. And it's usually a stub or a mock with no functionality. It's only there for type. It only satisfies type requirements, right? And it's there because you don't want to test all of even a function at the one time. You want to test various pieces of it. So you turn things off. I mean, we could do it with pointers and just say, if a null pointer, don't do anything, but we prefer value semantics and you can't have null references. So we usually have something, like I say, that supplies the correct type. The arguments that you're given are discarded, and you just return a fixed result, right? And that will look like here I have a DB interface with the normal operations you would have. And here is the process. So all I'm going to do is I'm going to derive a null DB, which just, like I say, fulfills the type requirements. But now when I'm testing this process function, I don't have to worry about any of the database stuff because I just want to focus on maybe some calculations that are going on in there. All right? And that's null-valued objects. That's kind of the type, like the methods of doing it. All right? So it's about 4. I couldn't find any more. But the other thing we have to do with dependency injection is when you have functions like this, which have side effects inside of them, if I have something, like I say, that just calculates the midpoint of 2 numbers, adds them up and divide by 2, it's easy to test. I drop data in and check the arguments coming out. But where I have classes like this that have hidden side effects, they're tougher, and they're the ones that we really want to get our hands on. For instance, this thing here might just return a success or error code. All right, but I really want to know that I sent the proper request down to, the broker that's going to fulfill a financial transaction. So let's talk about types of dependency injection. And the first one is, we're still on basics, all right, setter dependency injection. All right, what is that? It's sometimes called property setter injection. And what that is, if I have a class here, and here is my dependency, all right, and here's where the testing of the dependency happens, and I want to get my hands on what's being passed in and control what gets sent out. All I do is I say, look, I'll put a set function in there. I'll set it up. All right, and now there's my injection point. What do people think of this?
It's public.
Yeah, well, I'm looking for the public to use it. All right. All right, there's a few drawbacks with this. All right, first, the class will spend the time in an unusable state, right? I'll probably throw an exception if I try and call something on the unique pointer. All right, and it can change as the class is moving through its lifetime. That's probably something I don't want to happen, but can happen. And right, the function is probably not used in production because it's too risky someone not setting this. So people set in like a default, and you can come in later and set it to something else. Did all the transactions stop before you got there or not? You get these edge case bugs. All right, so I said this, you don't use this either. All right, so don't use it. If you're finding you using it, there's probably a better way to talk to someone. And that setter dependency injection, I'm taking that off the table. All right. So what about method injection? All right, so that is where I have a function. Again, I have a function like this, and I'm just going to drop in my dependency right there in the function signature. Okay, just like this. All right, a method dependency injection is pretty simple. All we're going to do is say, here's what I want, and I drop it straight in the function here, and here's my injection point. All right, and it's very honest. You can tell looking at the function what it's using now. So that's a big advantage. But what problem have I introduced here now in an existing code base?
You have significant complexity. You're going to have to find every place to execute this code.
Right. If I just hit the compile button, go make me my new, just make this change and make it, I'm going to probably have errors all over the place. And right, and woe and behold, if this is external, you're giving a library to someone else, you just can't have this kind of changing of the interface. So that's one of the problems. The function signature changes right when you use it. But there are ways around that, and we will talk about that. All right, so that's method injection. And then the last one is constructor injection. And apologies to the functional programming crowd, but you don't have this. All right. So what happens here is I have my method injection like I had before, but let's say the dependency I'm dropping in does not change at any time for the execute. It's constant. It stays around the whole time. Well, what happens if this happened to be in a class? All right. What I would do is I would just move that up there. All right. And now I have my dependency being held in the class down here from when I injected in the constructor. All right. And nothing changes. All right. The function, as you can see, hasn't changed. So the process function, we have the dependency, the testing, the constructor, as before, and the function signature is unchanged. Have I introduced any problem here? Anyone?
Change the signature constructor?
Yes, you just hit the go, and I've done this, and all hell breaks loose, right? So you got to worry about this as well. Yes.
You've also introduced a lifetime thing that you got to be worried about. You're saving the state of a reference into this class, and you now have to be worried about that thing staying alive for the entire.
Yeah, but I could put a copy in there if I wanted.
Sure,
right?
you could.
Okay, so that is a concern, but not really one I'm looking at here. The other one is you get a better class invariant, I think, right? Where you're saying whatever's popped in there stays there, and no one messes with it. All right, so that makes your class like easier to reason about, especially when you get bugs and errors. So that's constructor injection, and I think that's the end of the basics, which should have taken roughly half an hour. Has anyone any comments on that? Did I miss something? All right, pretty comprehensive. Oh.
What did you mean by the functional people don't have access to constructor injection?
Because you don't have classes.
Well, you've got data records.
Right.
Those are not classes, but they're
Are they supposed to have a lot of functionality attached to them?
They have functions which operate on those things.
Okay. All right, well, I think you're probably not in the purist camp if you do it that way, but that's fine. I just think that you generally are not using classes, so you can't have member data, that's all. Right, which is state, and I know state and functional programming is kind of passed around in a bag somewhere. All right.
Okay.
All right. But I'm happy to
I don't know if
debate
I agree with
that.
that.
I debated that with him just yesterday. All right. Exact same thing. Anyone else? All right, so let's talk about conceptual dependency injection. All right. Which people are very good at. That's not that hard. Right? All I say is I'm going to control all the dependencies in my system. And it's really easy. I just identify the components that I want to be able to change, right? So I'll be able to capture the inputs and control the outputs back when I'm testing or even different functionality. And then I just have to say, where am I going to insert these dependencies? With anything that's constant, right? Just put them in the constructor and drop all other dependencies into function method calls. Right? That's it. Everyone okay with this? Yeah, okay. I was not okay with this, right? Because this is not the real world, all right? This is okay when you have a toy example and you say, well, let me just take my dependencies because I have a house and it's got a heating system and I just drop the heating system in the constructor. I can change the heating system. It's like, yeah. That's great, but my house has a billion things inside of it that needs to be specified, not just the heating system. So we find this problem in the real world, and it's what I call we need to go to what's applied dependency injection. Right? So when you have math and you've applied math, how do you actually get this thing working in code bases that frankly sometimes go really against you trying to get this stuff done? All right. So let's talk about the easy stuff, right? When the object's full creation that you're looking to influence is hidden inside the function or the class, right? There's no handle to inject that functionality, and if that needs to vary based on properties, what'll happen is you'll eventually get singletons used or contexts or these big global data structures, right, instead. And what that looks like is something like this. I have a class. I got a function in it. Here I have, I want to change out the processor. There's no handle in it. Obviously the solution there is just to drop it straight in, but you'll get stuff like this. And I frequently run across this where someone's saying it's not just a processor I get. I got a whole rich, class, a bunch of classes to do with this thing here, a whole rich hierarchy, and I have to figure out which one to get. All right. What am I going to do? Drop a singleton in here? Right, you can't. right? And I actually gave a talk about how to get rid of singletons because I don't like them. But this is something we got to get rid of, and that's a roadblock. And we're going to go into that a little later. The other thing that is a roadblock to dependency injection is when you reach through multiple objects. Right, you were seeing this in a talk yesterday, right? When you then need long chain and mock classes for boilerplate, and you're breaking this law of Demeter, which is the principle of least knowledge. In other words, I don't need to know about all these other classes. I just need to know what's at the end. All right, so reaching through multiple objects looks like this. This is a real piece of code, all right, that I had to deal with. Imagine, now the updater in that class, I could make a mock updater, all right? And that mock updater would have to start looking a bit like trying to make a class functional, where there's a bunch of functions that just return this, so I can keep calling it on it, right? I have to put a processing context function on it, an exchanges function on it, a get function on it, and in the end just return the tick helper, all right? So what do you think I did when I refactored this code to do? Because I had to make this into a unit test. What do you think I did? I just dropped a tick helper in, right? The legacy tick helper in. Like, why that big long chain being pushed in? All right, it's something you don't want to do. Again, the law of Demeter, who was, I believe, the sister of Zeus, says just talk to your immediate friends, right? Just ask what you want. I don't say, Alex, can you ask him who asks him, ask him, like what time the drinks are being served tonight, right? So why don't you just walk over there and ask him? It's the same kind of thing. All right, so that's reaching through multiple objects. Anyone ever see that in code? Yeah, you see it a lot? No one here sees it. This whole front part of the row doesn't see it. John, I know I've seen inside your codebase. I know it's there. All right. Okay, so the next thing is I can have too many dependencies in a class. And what that means is I got 35 dependencies in my class. All right, you seen that big camera class in Tony's thing yesterday? And you're like, well, I can't pass 30 parameters in, right? It's too much. It's impractical, right? So now we talk about what about refactoring for dependency injection? And when I gave this as a dry run, one of the people said, well, yeah, here's how you solve it. And this is the way he said to solve it, right? So here I have an execute which takes a DB, a com, some kind of file loader, calc, string, double string. Hopefully I don't transpose any of the strings, cache, const date, a bunch of stuff, right? And I say, well, that's way too many to ask people to call. So the way I get out of that is just put a bucket together and dump all my stuff in there, all right? Is this like functional programming?
You have mutable objects.
All right, so does anyone think this is a really good idea? All right? You think it's a good idea?
I like it.
You like it, okay. You're a functional guy, right?
Partially.
All right. So I think it's a bad idea, right? So don't do this, right? Because all you've done is you have taken the problem and just moved it elsewhere. All right. All you have is you have this big God bucket now that has all kinds of stuff in it. People generally won't make a bucket per function. So they'll have the one bucket that just gets all kinds of stuff added to it. You don't know which part of this are used by your current function. And the stuff you're not using, you have to set up anyhow. And you get into all those problems of dragging in extra dependencies, right? This can work when you're having coupled data, like I have an XY coordinate and I bucket it into a struct. There's stuff, I have a circle and I have a coordinate and I have a radius in it and you bucket it up that way. That's correct. Roy, have you your hands up or are you scratching your ear?
If I would call this bucket another name, like config, I have prod config and test config. Is it any better?
Config helps people wouldn't ask me about because it's one of them gray areas that we have to change how things work. But I'm going to say it's not even that it just acts like a class that's got too much state in it, right? You've got too much state in the bucket, so you're not helping yourself out. All right, so that's not the way to worry about when you have too many dependencies. I think that the better way, and this is a symptom of what happens, is you have classes or hierarchies packed with way too much functionality. Right? Over time, people have just pushed stuff in, and no one's really thought, should this be in the class or should this be something the class, right, reaches out for, right? So we have these things, I call them God classes because they just have so much stuff in them, right? And they're very inscrutable, right? It's like gazing into the infinite, trying to figure out what to do. They got all this stuff in them, right? And because they have so much stuff in them, you can't inject all the dependencies. Now, you might get away with it by saying, look, I'm only interested today in that dependency way down there, and that's the one thing you drop in. But over time, you're right, the entropy is gonna catch up with you. So when you want to do a proper handling of something like this, I call it refactoring for dependency injection. We have this class that's a godlike class. It's got tons of stuff in it. And this is the real journey I've been on. So I have these classes which have way too much stuff. All the individual functionality of lines of code in them, all right? And when you kind of look at it, I had to go in and kind of separate things out a little bit. When you go in, you find out there's all this stuff going on inside of it. Here I have 8 things, right? I'm going to verify things are correct, getting pricing and volumes from trades and securities, what actions I can take on it, what are the rules to apply, business logic, when I send it out places. But this is like a bunch of dependencies. If I was to try and say, well, all I'm going to do is lift these 8 dependencies out and drop them in the constructor, I don't know, I wouldn't like that. It's too much, right? And what happens if each of these has 3 dependencies that's on its own, right? Now I'm dropping 24 dependencies in, right? So it scales up. So what do you do in a case like this? Well, what you can do is you say, look, let me take all those pieces of individual functionality, pull them out of the class, and make them into their own very small base functional classes. I remember I was talking about that diagram where you have your data, then your base functional. So I pull these guys out. They're really not doing very much other than working with data. And that means that they're usually easy then to do this testing on because you just have to put the proper data in. They don't have these side effects which they reach out everywhere. All right. Now, I still haven't lessened my dependency count here. I've just made it that at least now I can test some of the base functionality. I don't have to put the whole class up in a pocket universe and run it. All right. So, but when I look at this and I see all these pieces of functionality, I'm like, you know, there's a kind of a higher abstraction sitting in here, right? A bunch of these functions, what they're doing is they're gathering information from the security and stuff like this. The next, they're applying a bunch of rules to how this data should look. In other words, producing the results and changing the state. And then the last one is distributing that state out, right, and doing the side effects. All right, now, as you see, I still have all these dependencies because I'm doing all these calls out. But what happens is when you do this, you typically find that there's a lot of glue that was there inside of your big class that was only to do with the gathering information. So what happens is the glue goes out a lot as well. All right, so you move that out. And now what you have is a much smaller class with only 3 dependencies, where you had 8 before. All right. And now what I can do is I can do unit testing on these guys. And what I will do is I will drop in, let's say, I'll drop in the mock pricing class, right? And I'll push up the data and I'll make sure that I'm controlling what the sizing, actions, and data coming into this class. I'm going to make sure what comes out is correct. So now I have another layer of testing. So what happens now is these classes can just be said to sit inside of this class here. 3 dependencies. And if I want to test this, I can say, look, I'm going to put in my mock gather information so I can push information into this class, control my information. And my distribution logic, I'll put a mock in there to capture what the results are. And I'll just exercise the business logic inside of this class. All right, so now your higher abstractions. Yes?
But don't you still need the dependencies for those bigger classes?
Oh, yes, you do. And they're right here. Okay? So if I say, well, that's how I test the big marshalling or application class, I can take the gather information class out, and it now has its own set of dependencies, but they're hidden from the marshalling class. It doesn't need to know about them.
But you need to create the gathering information class and to provide it with the 3 injections
Yes.
So you still have to provide all the injections to the larger class, the godlike class, but in a different way.
Yes, but that the different way is key. I'm going to show you how that works. All right. So here I'm able to test my gather information by maybe just injecting the pricing, the sizing, and the actions in and making sure it delivers proper data to whatever's asking, which would be the marshalling class. And then at the bottom, I have my pricing class, one of the base functionals, where I can say, listen, am I getting the price, all the testing of how the pricing is done. So I have this layered dependencies and this layered testing that goes with it. All right. Anyone got problems with this? Any questions? Simple stuff, right? That's a proper way to lower your dependency count instead of just putting it into the bucket. All right. Now, the other thing I seen happening was we get functionality splintered. So in one case, we have all the functionality packed in one spot. The other thing is the inverse of that, where the functionality is fragmented all over the place. All right, so there's a function calling pieces that it needs to do its operation, and they're split everywhere. All right, and they're the only ones calling this function, so it doesn't seem right that should be happening, right? So you get this fragmented throughout both an inheritance chain, which is what I faced a lot of, or utility classes. All right, and you get a lot of duplication through the code base because people don't even know it's there. It's in this giant utility class of 50 functions, and people write their own and put it into a different utility class. All right, you see tons of that. So how does that look? Well, when I'm doing refactoring here I'm doing some verification functionality, and I'm reaching out into 4 different utility functional blocks that can be pure functions or classes, so I can say if this thing is verified. And I have right now, just on the verifying of this, I have 4 dependencies. All right. Well, what if I was to say, look, these 2 dependencies here and these 2 dependencies here are used for verification only. They're not a generic utility. And I said, this is a component. Right? I dragged all those pieces together, and now I'll make one call to my component class. Right? Now I have a single component I'll be dropping in, and I can mock these out and have my dependency injection. Right? But I also get unit testing on this again. Right? I can test all the code out. Now, the other thing that happens when you do this, both of these forms of refactoring, is that you then see where all the duplication happened. Right? You see where you have conflicts. So in other words, this thing here is doing it one way, this is doing another way, which is the right way. You can see conflicts, right? Especially when you get stuff sprinkled through an inheritance chain, right? Because they're in this class here, this class here, this class here. This is a virtual function that's got a processing function. Well, it just says call the base function. Base function calls some virtual functions on it, and instead of calling the functions there, it pops all the way back down into your derived class. Does some stuff, it calls a function that goes back up into the base class, right? And you have that fragmenting through your inheritance chain. It's a really bad way to use inheritance, but you have that fragmented throughout your inheritance chain. And because of that, people can't see what's not a lot of code in the one place to make it sane, all right? And when I've been doing this, I've just been taking blocks of code and sandwiching them down because they're all in the one place. And if they're all in the one place, what can I do? Local reasoning, right? I don't have to go look at 100 classes, or it's spread out through my code base. I look at the one class where I've gathered all that functional, so I can do functional reasoning. All right, so this is, I will call the main roadblocks I have found in my journey through a 30-year-old, very large legacy code base, which seems to have been designed orthogonal to dependency injection, right? It's got singletons everywhere, it's got God classes everywhere, and the people who've been working with us a long time say, I don't really know what goes on in the code, right? And when we get a problem, it's really hard to figure out where the problem is, right? Because the only thing I can do is like maybe run this big integration test, which gives me, I don't know, Chris, how many lines of state do I get when it goes wrong?
Like, I mean, out of TPC, like hundreds of thousands. Like, you get crazy amounts of output.
Right, because who knows what state is wrong? Let's just throw the whole lot out there. All right. Okay. So if that's the roadblock, how do you get onto the highway express for dependency injection? How do you get on that freeway and just the autobahn and let it roll, right? So object creation should be done outside the logic of the functions, right? And that is done by either passing dependencies in directly, which is the one that we do a lot, or by having a dependency supplier, right? Where I say, hey, I don't know, like when I go to do something, I'm just going to say, give me the dependency and I'll use it. So it's not passed in, the dependency supplier gets passed in. And we're going to see that in a little bit, all right? This is not the service locator model, all right? I'm not talking about service locator. If you don't know what that is, it means I just have some essentially big, huge factory in the class, and it produces anything that all my system needs. I just say, hey, give me this class, and it gives me the proper version of it, all right? And that drags a whole bunch of dependencies into your class that you don't want to know about. So we don't do it. But doing it for just the ones you need, right, with stud function, which is what I generally use, works. Any questions, comments? All right. I hope I still have you guys. I think this is still pretty simple stuff, right? Haven't lost you. All right. The other thing is invoke the methods on immediate objects. Don't be putting in these classes where you call X, give me Y, give me Z, give me, blah, blah, and then I get something back. Drop directly, drop in what is needed. I don't need to know anything other than what I want. I don't need to know anything about, I won't even go into it, right? Lots of stuff. The other thing is refactor your God classes, all right? So where you have classes with way too much stuff in, factor them. Now, I'm talking about local refactoring here. I am not telling you to refactor your code base, right? Because that's usually a 10-year plus effort, and you won't get it off the ground as a single guy, right? So locally refactor the pieces that matter, which are usually some of the heavy top classes, all right? And when you do that, you do functionality clustering into tiered abstractions, and then the whole idea is to lessen the dependencies in the class, right, to make it tractable. And then, refactor the fragmented functionality. This happens just when you have a lot of programmers don't talk to each other, when you have a very scattered code base, everyone just does their own thing. All right. I know it doesn't happen in where you are, but I've seen it happen over 20 years of consulting in different companies. I see it happen a lot, okay? So again, take the functionality, it's all over the place, pull it together in one component, right? And that will lessen your dependencies. So that is applied dependency injection, right? Which is nice when you're writing new code, all right? And the previous project I was on, which was called EMSX, and I have one of my work colleagues here, was brand new. We could write, and we could write it with dependency injection in mind. There was never a place where we had tons of dependencies, because then how are you going to write a test, and how are you going to get that test through code review? So there was a proper level of abstraction. It never got to run feral or become wild and overgrown, so it behaved itself. But what happens when you're in a legacy code base and you don't have this freedom, right? Because it's harder to put dependency injection in after the fact when code is released to production. Anyone want to say why that is the case? I mean, some people like the adrenaline rush of doing stuff directly on, on production code and saying, just let it rip. Let's see how that goes. Oh, I blew up production. Just roll it back, give it back to me, right? So where I am, that would not be tolerated very well, right? So code is not very malleable once it goes into production. People are relying on its behavior. People are relying on your interfaces, all right? So you can't just change them. And if you are an external dependency for someone else, you're putting libraries out there that people are using. You can't just change it and walk away, right? And say, look, I don't care. It's not going to work either. So large-scale complex changes are riskier and take more time, and that's why they generally die, right? Unless you have backing from right the way up on the management chain, right? Which they do sometimes, all right? But the preference is usually for a phase localized change. And what I mean there is that it's a change where all the stuff I'm doing, the dependency injection, is really cornered on one piece of my very large code base. But all the rest of the code base gets the benefit of what I did. All right, so you keep all your global, contracts is kind of overloaded, but all your global interface contracts stay the same. But you've changed stuff to make it much better to work and much better to reason in this part of the code. So that's the preference. But you need tools and tricks to make this happen.
Just before you move on, I'd like to say that large-scale complex changes, unless you have a specific reason for making the changes, it's not just that you need management support, it's that if you were refactoring the same code under different circumstances, you would make different choices, or at least I usually would make different choices depending on the circumstances. So it's usually not, even as an engineer, from the engineer rather than the manager hat, it's not usually worth refactoring for the sake of refactoring. You usually need a reason that you're making the changes that you're making.
Yeah, if I go to the business side of it and I say, look, I'm going to just hold everything for about 5 years while I do dependency injection and componentization and refactoring, and it'll be really great, right? I'll be laughed out of town, right? In other words, you can't put that kind of stop on it, right? So even like I ran for 2 years and I've just finished, I think today, migrating the whole of the ticker plant, tick processing fleet of machines from Big Iron to Linux, which was quite an undertaking, right? And that's taken 2 years with the board giving me, right, like, yeah, make this happen. You have to make this happen, right? And there's another talk I'm putting together about that, but that's for another day. But you cannot just do a huge change inside of a code base, generally, certainly in a large company, all right? So you're going to need tools and tricks. So let's look at some. So one of the problems I'll have, and I've talked about it a few times already, you're going to have an API that's used all over the place. Even if it's only in your own code base, it's used all over the place. Or it's a class with a bunch of functions, or it's a function, and it's used everywhere by a lot of other groups, right? And you can't just change that interface, right? It's not allowed, right? And with method dependency injection, we already talked about this. What happens is I add my dependency here and I cause havoc through the code base, right? So how do I get around that?
Overload.
Overload, maybe. But then what, do I write the function twice?
One overload calls the other.
Ah, okay, yeah. You see, well, first thing you can do, right, here's your injection point. First thing you can do is just put a default in. All right, so you can just say, listen, anyone that calls this was just the key in the string, still gets whatever's going on. The production stuff happens in the default calculation here. And when I'm doing my own testing, I'll put in some mock calc. All right, but defaults have kind of weird things. Oh.
Wasn't a default just an overload of nowhere without that argument?
Is that an overload? No. That's not, and as far as I'm aware in the language, that is not an overload. That's one function.
Yeah, this can, by making this change, you can break code that might be referring to that method's type. And you've changed the method's type.
No, you haven't.
Mm-hmm.
Yeah,
I also have changed, I haven't changed the API, but I've certainly changed the ABI, right, underneath. Right, so, and I seen a talk a while ago, many years ago, about how defaults can act weird in some corner cases.
I think what he's referring to is just that if somebody's taking like a function pointer to this thing, like that's going to become
Yeah, yeah. No, it's valid, right? I've changed the function signature. I haven't changed the way you call it, right? So that's the hair I'm splitting here. And the reason I'm doing this is so that 50 billion other people calling this function don't have to go and update their code, right? Because it's not a priority for them. All right. The other way it can be done, right, is, right, what someone else was saying down here, right? Just a forwarding function. In other words, I leave, I can say, look, I have the same function as before, and what used to be the process function of 2 arguments now takes the 3 arguments. And I'll just have a default being injected in here. So I'll just do a default injection of the functionality that most everybody else expects to have. All right. So if we're doing constructor injection, same kind of thing, right? I can say, look, I have a calc, and I'll just put a default in. Do people take addresses or types of constructors? I don't think you can, right? So you don't quite have the argument. However, right, you're still able to use delegated constructors, right? Which all it means is whatever was your main constructor, you add the extra argument on, and then you just say in my delegated constructor, I'll add a default argument on and call the main one. All right, and this means all your contracts stay the same. Oh, wow. They all stay the same, right? So you don't have to, again, all the wide code base that is using this functionality doesn't even know something has changed, hopefully, all right? But you're getting all this dependency injection goodness and testability, and, right?
Peter, does that imply that your default is a singleton or a global object?
No, it's just a piece of, no. I've never created, written, or intentionally used a singleton
But
in
how
my
else would you
career of
classify-
30-something plus years.
Okay, how else would you get the default object? On the
Well, I'll
basis-
show you in another slide. It's just a piece of code that says, here's what they're doing, all right? So
I think what
it could be a simple
means-
lambda.
I think what it means, because you used L-value reference, it must be something that is
must be
not
created somewhere.
created on the stack there. It must be an object that already exists. But
Yeah.
if you would use const reference or something, you can create an R value.
Yeah, the implementation detail, but yeah, all right. I'm not so much worried about that. Make a const, do you want to move it? Do you want to copy it? Are we going to use move-only functions, or what kind of defaults are? But the actual code that's the default does not have a singleton in it, or shouldn't, right? If it does, it's because some other part of the code base is doing something strange. Yes?
But what if we like start to refactor the code, just passing the real guy? So basically you can switch to your testing function. Or whatever.
No, I expect people to use the real guy. I mean, I will send out emails and hassle people and send PRs to the code base. Please call the 3-argument constructor. And they'll say, yeah, but I'm not that interested or busy. And by the way, my group is more superior in power to yours, so I'm not doing it, right? You do what I say, I'll not do the other way around. All right. I know it doesn't happen in our very, what is it, Star Trek universe type company setup. All right, but what do you use? Default arguments, delegating functions or constructors, forwarding, is how you can say, look, I've changed arguments, but the calling of them is the same. And I believe if you use the forwarding, I don't even break the ABI. Certainly I can make it happen that it doesn't do the ABI. So let's talk about some other stuff. Encapsulated functions are dependencies. So what I mean by here, and I struggle to try and figure how to put this in a good way, it just means a function that does a bunch of stuff, but doesn't reach outside itself, has no side effects, and really all the result just comes out in the return value. Right, that's what I mean by functional stuff, right? Encapsulated.
Isn't that a pure function?
Is it? I don't know. Is that a pure function?
If it has no side effects.
Other than the result coming back.
Doesn't
Yeah,
matter.
okay.
We'll
So
say
pure
it's
functions,
pure
that's
function.
the next time I give this will be pure functions, not encapsulated. I couldn't figure out how to call it,
If
right?
you can call it and then call it with the same value and get the same result always forever, then.
Yeah. Okay, so cool, pure functions. All right, because I'm not a big functional guy. I didn't get into it. All right, so here I have something, right, that's taking, and by the way, this again is based on real world experience. I have this thing called fast data and a calc dep coming in, and fast data reaches into a cache and has all these external dependencies, and the calc dep reaches into a database to figure out which of the calculations I should do and pulls down some of the factoring quotients that are needed. And it's all, they're all very complicated. And someone really has inverted how these classes are used. In other words, inside of this compute, it may ask for stuff which causes it to go to the database or causes it to go to the cache, right? As opposed to just giving it a plain old data structure. But you find this a lot in older code bases, and I run into this. So how do I test the compute function here? Anyone? How would you test this? I want to make sure when I put particular fast data in calc that returns and all these, their various APIs, that I get the right answer out. How do we do that? Can't pass in test doubles. I got fast data and calc deps. All right. right? I'll just mock them out and say, listen, I don't care about all that funny business that goes on in your plain data types. All I'm going to do is derive off them and just push back plain data, right? And these are the functions that are usually down what I call the base functional parts of your system. You don't really have to worry about dependencies. They really don't usually don't reach into external pieces of your code. Yeah.
Are we assuming that the types you're passing in aren't virtual themselves?
What do you mean virtual?
They don't have a virtual destructor, but you're deriving from.
If they have, so what?
You could have some possibility of undefined behavior if you don't have a virtual destructor, and if you access it through the base class.
Oh, that's whoever wrote the CalcDep class, right? This is not, I don't have to worry about it in my mocking. If someone wrote fast data and the virtual stuff, yeah, virtual destructor, or just saying it should be default, yeah, but that's the original class design, right? It's not to do with dependency injection. All right, so it's easy, right? So it just means when you're not using, when it's a pure function, all right, just pass mock classes in. No matter what is being passed in that has all kinds of dependencies, just pass your own very, very simple mock class in. Boom, you're able to test these functions. All right, let's keep moving. What about dependency injection for lazy object initialization? All right, this is a real case I came across. All right, so for lazy initialization, you're not able to pass in a constructed object, right? The kind of things are going in opposite directions, right? And I say this is real. This is a real thing that I went through, right? So I have a class. I've named it to be a little more. It was called lazy obj, right? So I thought that wasn't very good, right? So here we have a dependency with this thing called a DB helper in it, all right? And I have the lazy injection. So when people call the apply, so I'm just taking this object and moving it through without accessing it. It doesn't bother going to the database and pulling out the data. It just passes it on, right? And that's why you have the lazy, the lazy injection going on here. So you see, if anyone calls one of the functions that it really needs the data, it calls this ensure loaded, who just says, listen, if you don't have something inside of that unique pointer, well then call create DB helper. Right, which did actually lead to a singleton, right? But it doesn't matter here. So how do I do my dependency injection in a class like this, right, where I want to be able to put my own DB helper in?
Pass it in a factory function that has your dependency injection underneath of it.
That's one way. I hate calling factory functions because it sounds like they're doing lots of stuff, all right? But yeah, here was the first draft of what was being done, right? So what happens is they just said, look, constructor injection is better. It doesn't change for the lifetime of the class. So all I'm going to do is say, look, when I create this, when I create the class, just create me that DB helper, right? Anyone see a problem with this?
It changes the semantics of the class, like what if it never called ensure loader?
Well, it just means I can get rid of all the ensure stuff, right? Because I don't have to ensure it's loaded anymore. It's loaded at constructor time.
Only except create DB helper may probably return null pointer. Unless create DB helper is actually allowed to return a null pointer.
No, it's not. It doesn't. It returns you something to use, or else, I think, true an exception. All right. So the problem here is it's not lazy anymore. All right. Where we've just taken it from lazy to we do it every single time, and this can have real ramifications on your system. So you're not allowed to do stuff like this, right? So you have to be able to work around it. Did someone have a question?
I was just going to say you might run into an issue if you end up having static instances of your security class, because you said that reached into a global area, and
Into a singleton, yeah.
You might have differences in your static initialization type of.
Because the create DB helper went and reached somewhere you don't want to even know, and then said, well, which of these other singletons do I give you? And then that singleton gave you something back, which was the DB helper.
Where is the create DB helper defined?
Elsewhere. It's just a function that gives me the DB helper. All right. So this is not going to work. All right. So the second version of getting this done was, all right, so we have a dependency here. Let's put this in here, right? Setter dependency injection, the one I crossed off the list, right? And I caught this in a code review. I just managed to, just happened to be browsing. I was like, what? I just like subconscious spotted something, came back. It was a set DB helper. And you notice they don't even just say, let's set it. They say, like, if there's nothing in there, set it. Because I'm worried if I'm in some kind of production context, someone calls this and puts some test one in, right? And it turned out that the only place this set DB helper would be called is in the testing functions, right? Except it was worse than that. It actually turned out that it was in the hot path of our processing, what called that, like what called this thing. And what happens is this, the other thing would return a null pointer and it would say, okay, there's nothing in there, we don't call it, right? So in other words, it was just not the way to do it. You have all kinds of problems with state. So this was thrown out, all right? So how did we, let's go back to where we were. Here's the class as it was, in case you forgot. So how did we figure this thing out? And it's kind of like your solution, except I didn't call it a factory because I don't like that name, right? So what I did is I said, look, what if there's a type, right? If I provide DB helper, right? And what I say is, look, this thing gives you back that unique pointer once you give it that string. All right. Now I'll just have to rewrite the class, right? And I'll walk you through it. Here is, I had to add another member. Again, this won't affect anyone who's looking at this class. It's API, so I put a provide helper in here. And then I say, look, in the constructor, right, what I'm going to do is have a provide DB helper call, and that's going to default to what was there before. Right, so now, I don't have to worry about, I haven't changed the constructor. Right, and down here, I changed that to call the provide DB helper. Boom. We have it. Right, it only when someone says, I need this thing, will I get to provide DB helper. And now I can drop my own in. So instead of providing the DB helper, which was a huge, one of these huge classes, I can just put something of my own in. What would people think of this as a solution? Is there a better way of doing it? You're doing a bit of this. You're doing this, which made me thought, like, maybe there's something else you want to do. James.
You won't like it because you crossed it off your list, but there are cases where I have seen this kind of factory function or whatever. As long as it's available in another translation unit and I don't need to link that translation unit, I can link or mock that and provide my own implementation, which generates.
And right now you have gone over to the dark side, James, right? You're talking about link time substitution, which I gave you a couple of reasons not to do it. Yes?
You could also define a class template like basic security, where you take the create DB helper as a template parameter, and then your class security could be the implementation of that with the template parameter. That's your production one.
Are we templating the class or the constructor?
Neither. You're adding a class template, but the class security becomes an instantiation of that template.
Okay, all right. I must remember that. It'd be great if you did that up in Godbolt for me, right? So, and then come with me, because that's where I say the rubber meets the road, right? That they actually work. Because lots of times when people have said to me, want to try this? When you try it, there's a whole bunch of side problems. So, but that does sound promising. I like the sound of that, yes.
Who is that extra parameter there for? Is it solely for testing, or is it for generic, anybody can make use of this?
Anybody can make use of this. Testing is going to make use of this, right? So in other words, up until now, right, so again, this is what happens with an older codebase. Really what should happen, right, is that you're dropping a particular helper in when you need it, not this thing here where we say, look, I'm going to give you a DB helper and you've no idea where it came from or how to set it up or something. Here we can say, look, you get it directly from here's where you get it from, right? And I can control that. And down the road, instead of saying the DB helper making the selection, I could say something else just makes the selection and drops it in here. But let me show you, because we're going to run out of time. Let me show you. This is like one of the ones that really put me on the back foot, right? So unexpected snags when you're doing dependency injection in a big older code base, right? So here I had this class called header, all right? So, and I said, okay, I need to have a mock version of that. So I said, all right, so it's got this virtual get dividend, so I'll just mock my method out there. Some kind of set model, I'll mock that out there. And I went off and I did a bunch of unit testing and a whole bunch of stuff that hadn't been unit tested before. And then I said, okay, I'm moving up the higher abstractions. Oh, I left a piece out here. Here's another piece of functionality. I said, okay, it's calling a header function is type. All right. And this is what I found. All right. Right. I have a template member function which cannot be virtual. Right. What am I going to do here? I just run into almost an insurmountable roadblock. Right. But not quite. So what happens is like, oh, damn, let me go look at the implementation of this. And I seen, to my surprise and delight, there's a general template function and there's a fully specified template function, right? That just happened to be the one I was using, right? Which is a kind of a stroke of luck. So all I had to do was say, look, let me add a virtual override function or an overridden function here and just get rid of the template here, right? And I actually did put the override keyword in there. It's just not there right now, I think. Oh no, you can't put an override in. So what happens now is I'm able to go and say, look, mock method my is type on the string. All right, which was just, I think, a stroke of luck. And I was like, well, what am I going to do if that wasn't the case, right? What if I have it that it's something else that I have to go through the main template function? Well, now you have to go back to the point of sale. Where is this being used? And it was being used here, right? So some sort of string value been put together, and I was calling this is type to get something back. So again, I said, well, let me pull out the stud function again, right? All I'm going to say is, look, there's a calc and an int, and I want to type num back. All right, and then all I'm going to do is say, like, put down here, no one has to know this processor has a new type inside of it, which is my dependency. Down here, and then over here in the constructor, I'm going to inject it. All right, so far so good. Hit the compile button, we have trouble, right, because I've changed the constructor. So then I said, okay, well, what does the real type do? It just calls calc.isType on my value. All right, and now I'll just put that in as a default. You could put it in as an overload, right? You put it as a default, and now I'm golden, all right? And for testing, I can say, instead of all that nasty business with singletons, just return me type num A and make sure there's type num A stuff and do type num B stuff. All right, so now I have dependency injection here. So that's how you solve it. Now I gave this as a dry run before coming here because I do it with a new talk. And someone said to me, you didn't solve the actual problem, you sidestepped it. And I said, well, maybe I did. Because I just had it. He said, what happens if you had tons of types? Are you going to put like all these different, factory-like functions in there? Like, it's going to become unmanageable again. I was like, oh, so you mean what happens if I had something like this? Right now my solution just falls to ashes. There's no way through this. But wait, what did we talk about earlier? Types of dependency injection. Alex, you're a dependency guy. No? All right, look. Here's the type I'm trying to grab a hold of to get the inputs, control the outputs, right? Which is what dependency is. I just added a new type in my templating. And I added the concept that I did a while back. So now what happens is I can drop in my own calc. So here's my injection point. I'll put in my real calc engine. I can make that a default so it doesn't change. All right, and I go back to my thing here and I say, okay, that doesn't work. So my mock header is actually just going to be these things here, and I'll drop them straight into when I'm doing my testing, straight into the function as a template parameter. Everyone happy with that? So what's the solution for when you get these kind of snags? Well, templated functions when you're using inheritance. It seems like the wrong thing, right? Inheritance when you're using inheritance, templates when you're using templates. So you can turn it into a regular function, which is what I did, because a fully specified template function is just a regular function. For limited types, you can add type erasure, so have the function call, some type of function call. But in reality, what you should move to is template, right? You have templates all the way down from there anyway, so it shouldn't be an issue by adding one extra template parameter, right? And if you want to do it really nice, you can add these guys in as a concept, okay? So let's go back to the dependency injection myths, or myths. It's simple. It's not. It's generally very hard in the real world. At least I find it hard, all right? Only for simplistic systems. Well, simplistic systems make good examples, but they don't help you when you're in the real world much. Overkill in smaller projects, we talked about this, forget it for now, easy to add in later. I can tell you it wasn't easy to add it in where I am, right? It's like hell on earth trying to put this stuff in, right? So let's talk about the truth about dependency injection, all right? It's hard for real production systems. Anything other than a toy system, it's hard, all right? It takes real discipline. Properly factored code is the ultimate key to dependency injection, all right? For anything that's not a toy example. And when you factor code, just think of all the other benefits you get, right? So give weight to doing local refactoring of your code. Because if you do global refactoring, you're probably dead in the water, right? On a big, large system, too much risk, too much change all at once. Give weight, and when you refactor code, you spot a lot of other things. You spot unneeded dependencies, stuff that's in a function, you're like, why is that in there? Maybe someone's using it one day and got rid of it and didn't clear out some other function. All right, I didn't want to change the interface. You spot conflicts. I spot tons of conflicts in the code. Where in the inheritance chain, they're saying, this function does this. The function that's in the inheritance overloads it does something different or returns different types or all kinds of squirreliness. And you go and say, well, what should this really return? So refactoring gives you a bunch of stuff and dependency injection kind of folds out of it, right? So this is really a refactoring talk is what I'm saying. Anyway. Poorly formed code needs many tricks to get dependency injection in, right? And the tricks are all there to make a global users not notice the change, right? And that's kind of what you have to do. And it improves the flexibility, reusability, and that just means the testability of a system, and you get better long-term maintainability of the code by having dependency injection because you had to do the refactoring for it. So ultimately, dependency injection boils down to lessening the number of dependencies that need injection in any particular functional code block. All right, and I say you have the horizontal abstractions, which is where you grab stuff from all over the place and you pull them in together. That's the one side. I call that horizontal because they're all sort of at the same level, usually free functions. Or vertical abstraction, where you take this class, which is way too much going on in it, and layer it down, right down to base functionality. And I call that vertical abstraction in your code. And that's it. Thank you for coming here. Now, we have a few minutes. Has anyone bar you two?
You have to call on me first.
All right. Mrs. Shaker.
So I wonder how you would categorize this. Something that I found really helpful with managing dependencies is continually returning to your main thread of execution. And I don't mean threading from like a multi-threading paradigm perspective. I mean like just from your control flow perspective. So like every time you have a function, you're doing another branch. And like really looking at your code and trying to return back to that main thread as often as possible. And I found that was really helpful because it prevents you from having to thread like a dependency down multiple call stacks. And I don't know what that kind of refactoring would be called, but.
It sounds like it would be a single layer of abstraction. You can only call a function or a function in the class that can't call anything else. Because if it does call something else, you're now into an abstraction below it.
Yeah, maybe like that. Like return statements are your friend. Because anytime you need to add a dependency, you're probably only adding it to like one branch out of your main control flow. So I found that helpful.
Okay, I don't think that would work well where I am. But maybe when you're writing code from scratch.
I was refactoring my own code.
Okay, so if you're doing it with your own code and it's sort of, I'm going to say smaller scale, that stuff may work. Neil.
Do you think with C++26's reflection that we might get a new method of dependency injection with reflection and code injection?
So if we get reflection in C++26, and there's a lot of problems, I don't actually know what it's going to look like. I know it's going to be something along the lines of I can ask a class or a struct, what do you have, right? And maybe filter them down a bit, right? That'll be good for hopefully things like serialization, saying I have automatic methods being added to a class, enums to strings, these kind of things we just have to program over and over again where, you know, and some people have come up with ways of doing it that's pretty dicey.
Let me respond to that.
All right, you respond.
Reflection could be used, but the class that you're injecting into needs to cooperate.
Mm-hmm. Yeah, you have to be
You
aware.
can't take old code and use reflection to magically inject your dependencies. It needs to be a cooperative effect.
So
I'm not sure if it's the best way to do it. That should still be explored.
when we get some kind of reflection, I'd like to see the God bolt of that happening because I think it would be fairly tough, at least in the beginning, and probably use some unorthodox tricks if it's even possible. Yes, guy at the back.
I wanted to add something to this question, which was with reflection, you get a new thing that you can do where you could take a template parameter that's a reflected namespace and then splice into a qualified name so that you could basically inject which namespace you're calling a function from.
Yeah, I didn't follow most of that, but okay, yeah, I mean, reflection may help. I don't think it's going to solve the root problems that I was seeing. I think it might make put a little shine on some modern code that you're writing and like it'll be really cool and nifty, but I don't think it's going to help the huge, massive corporate code bases. Do you have a?
No, I think just a comment on that is, I think the namespace switching would just look like template type switching essentially in practice. So all the constraints of just swapping out one template type for another template type might apply there.
Are you going to cover this in your talk tomorrow?
Dependency injection was not my
All right.
topic.
Yeah, stop leading them on. Yeah, so, you know, and the other thing is, you know, in the older code bases, because they use a lot of inheritance, you generally tend to go down the inheritance coupled with type erasure, right? So the type erasure pulls in some inherited base class interface and you use it, right? If you're in a code base that's got a lot of templatization in it, I would say use the template approach, right? Where you just say, drop my classes in as template parameters. And I think that gives you better flexibility, right? I'll know when I'm in a very heavily templated code base, but it seems to me that would give you a better way of injecting stuff into a function.
I want to comment that you can somehow do it today by having a template class, a regular class that has a template conversion operator, and then passing it like as one argument to argument and so on, until you find something that matches the amount of arguments. Then it will try to convert all of them so you'll know what type you need to get, and then you can make access to some container and fix the proper type.
All right. So, but that's something you could take offline, right? It sounds like a very interesting discussion about using reflection, which in some kind of way or form. All right, I think, are we out of time?
Like 1 minute.
I have 1 minute. Anyone got anything to say? All right, then. Thank you.